Okay, so you have done your Bunsen burner lab, and hopefully um, hopefully you were able to light the Bunsen burner and were able to adjust and learn how to adjust the Bunsen burner. And you did the wooden splint and found that the top of the inner cone is the best place for heating. Hopefully you also verified with the thermocouple that the temperature of the inner cone is hotter than the outer cone. Usually ranges up to almost 1,000 degrees. And hopefully you also did your heating in the test tube and learned how to heat a substance over a fire. So day two, you're supposed to look at putting the match in the center of the Bunsen burner, and you would have, hopefully if you did it right, you would notice that the match does not light on fire. That's the main thing about that. And then some of you made it on to heating on the ring stand. Some of you did a low-tech way in which you just timed how long it took for it to heat up. And I had you start at the very top of the outer cone, which is where most of y'all heat substances at. And then I have you drop down into the inner cone so that you can see that the inner cone is going to speed everything up at a faster rate. And then you have your lower one. If you were able to graph with the temperature probes, that's fantastic, and make sure you include that in your report. And I try to explain to you how to handle that. And so I want to jump out to your report real quick. So your hypothesis you should have in there. You were supposed to write a hypothesis as to regards to what color flame was the hottest. Okay, so you're supposed to make a statement about that. Then you were supposed to take these words here and match them onto that diagram there. Then for your luminous data, what we should be seeing is hopefully, like a lot of you drew, okay, I'm not grading your artistic abilities here, but hopefully you have something like this, and you did your soot test, and you said yellow flame, and that when you had this flame, you produced soot. That was the main thing we're getting out of it. And over here, we had blue flame. Some of y'all might have also said on this one, this is wonders. A lot of people say this is a wandering flame. And there was no soot. That was the main thing to take off of that. Here, these were descriptions. So this was your qualitative description. So you would describe how the wooden splint would have burnt. This down here is your quantitative. So you have numbers for these. We have an actual number for that, and that's what we should have there. Heating of the test tube, so hopefully you wrote down your mass, and just getting you in a habit of writing it down. So 0.25. I heard some that said they had, I know I had somebody do 2.5 grams because they missed a decimal. That's fine. And the observations could be anything like you dissolved it. I know some people said it shook. Something. Match time, you're basically writing down your observations, if the match caught on fire or not. Okay, and you explain that. And then this is where a lot of people ended up at. So the ring stand, again, these are going to be your descriptions and time. So either A, you produced data from using the vernier, or you have time. Okay? You do need to go through your analysis questions. What is meant by a luminous flame? Should you use it? Why or not? Because these are important things we came out of this. Okay, you have analysis. If we did not make a graph, then you don't do the analysis. Okay, so if you did not use vernier, you don't do this part. Okay. But two you can do because it's asking you specifically what you're doing. And I'm also trying to bring back some math here. Okay, and again, if we didn't get to this part here with the graphing, then we'll just roll with it. If we did get to that part with the graphing, then it's included in your report. Okay, and then these are review questions again, extensive, intensive. These are review concept questions that need to be done as well. Okay. So now I'm going to go back to the presentation that I put together for you. And there's some more things I'm going to pull out of here before I end this. Okay. So first of all, again, we have the luminous and non-luminous flames. So I have some images here on your presentation to go back over it. Okay. And it points out some key differences between the two. Okay. Again, more on the flame, why we want to use the blue one, because it is complete combustion. That makes it safer. We don't want to produce carbon monoxide. And then we've bounced around this when we talked about states of matter. This is a key word here, kinetic molecular theory, because that just tells us that molecules are moving. And so the amount of movement that the molecules have determines what state of matter it is. And you guys saw that when you took the salt and put it in the water and you started applying kinetic and molecular theory to it by heating it up and causing it to dissolve. And that's also why I have that image there to help you understand why did the salt dissolve. And so I just added some images in here to help you visualize what's going on at that point. And then a review over extensive intensive properties, because you're still working on the vocab word and we're still using those words in our lab. And here again is here's density. It's not going away. So reminding you on how to calculate it again, what it is, what's its property, and so forth. Adhesion and cohesion, because as you start measuring stuff out, some of y'all used the graduated cylinders, some of you did not. So remembering to read straight on without a parallax, adhesion and cohesion and what it does. And because I was trying to introduce the graphing to remind you about the graphing and independent versus dependent variables, that your independent variables will be your x and your dependent will be your y. Also how to calculate slope, and we will be using our program that helps us calculate that as well. But we can manually calculate this too because it's rise over run. And properties of water are very important to everything that we do in here. So this slide is devoted to properties of water. Why is ice less dense than water is? Okay, the difference between fresh and salt water. Okay, density maximum is actually at 4 degrees Celsius. That's when it all gets packed in before it goes into its 3D matrix. And then finally, we worked on calculating percent error on the last lab. So here it is again as we keep working on it, although this lab didn't require you to calculate percent error, but I'm just trying to keep it fresh. And we're still practicing. Awesome job this week on your Bunsen burner lab. Make sure you get it all filled in and turned in. Looking forward to another great week next week. Live long and prosper.